Hello, students. We're talking about side angle, side triangle congruence. We're starting a topic that's called proof, and this is a topic somewhat unique to geometry. You have probably not done this a lot. In mathematics, this is like it's the really precise thinking that you do to convince someone of a mathematical argument. And it can apply to any kind of argument too. So deductive reasoning is a type of thinking. And the way I think of it is deductive reasoning is the type of thinking your brain does when it uses facts, algebra properties, definitions, theorems, postulates, and given information to explain why something must be true. It's the way that mathematicians win arguments. They say this thing's true and this thing's true, and we all agree that this thing is true. And then when you get to the end, you've created this proof for your argument. All right, let's take a look at this. When we have a figure or a shape, the first thing I like to do is just ask myself and ask you, what do you see? There's a picture. It happens to be a geometry picture. And I want to know, what do you see? And before I do any type of geometry proof, this is my first question that I ask myself. What do you see? Somebody said a triangle in class. Somebody said 3 angles. Okay, what are the 3 angles? Angle S, angle T, and angle R. What's marked on this figure? Good. 2 sides and 1 angle are marked in red. What are those markings telling us? Just that they're marked. What else do we see? We see the angle that is marked is across from side RT. We could say that line segment SR has a mark on it. Line segment ST has a mark on it. Angle S has a mark on it. And somebody in class classified the triangle. So can we classify this triangle? The triangle is scalene. That's good. And all 3 sides are different. Someone else classified it by its angles. What kind of angles are those? Good. The triangle is acute. Can we name the triangle? Yeah. What's the triangle's name? How do we name triangles? We put the triangle symbol and then we put the 3 letters of the vertices. So that triangle is named triangle RST. The last thing I want to know is, where is the angle that is marked? The angle marked is between the 2 sides. That's important. In a problem like this, we call this angle the included angle. It's you draw this side and you draw this side, and included in between here, you draw a side RS, you draw a side ST, and in between where you drew, that angle is included. That's the included angle in this triangle. So what we will, if I see a picture like this, I will say, hey, we have a side. We have an included angle because it's between the 2 sides, and then we have another side. So this is, if I see a picture like this, my brain is like, oh, it kind of looks like we have a side, an angle in between, and then another side. Side, angle, side. What's the math word for that? Included. That's an included angle. Just so you know, side angle side does not look like this. If you had a side and an angle and then the side over here, that would not be side angle side. That would be like angle side side. Spell that out. All right, so this also, now we have two triangles, and most of this topic, we're going to take two triangles at a time. And we're asking ourselves if they're congruent. Can I get this one to match up on top of this one? And there's two definitions for congruence. There's, are they the same size and shape? And can you get one to map onto the other one? And in this problem, I can see there's like a line of reflection right here. So I could say that if, maybe I'll name that line of reflection line M, I can say, yeah, these triangles are congruent because if I flip triangle UVW, what's the flip? Reflection, rotation, translation, reflection. Over a line M, I'm going to get W straight onto Z. I'm going to get U to match up on, sorry, I'm going to get U and X to match. And the order is important here, so I just messed that up. Okay, so U is going to match up where X is. Okay, and W is going to be where Z is. And except this is supposed to be a V. My goodness. That is the ugliest looking V I've ever seen. Okay, so X, U matches up with X. V is going to match up with Y. It can get a little tricky. And W is going to match up with Z. Oh boy. Okay, so why are these two triangles congruent? Because I can flip this one over this line of reflection M, and they would match up perfectly. Okay, this would match up, this would match up, this. So these two triangles are congruent. Although that's a way to prove triangles are congruent, we're going to practice two-column proofs as a way to sort of strengthen our ability to do deductive reasoning. So we could show that this one's going to rotate and maybe flip and then get S onto Y, but we're going to practice a different way. In this way, we're going to do 5 every day. We're going to do 2 together in class, and then you have 3 to practice on. So here's how these work. This is going to be the most straightforward one ever. So you have the figure here, and you're supposed to prove that the two triangles are congruent. I'm just going to take you through how to do this. So you're going to first draw this figure. Second, you're usually given the given and given what you're trying to prove. Okay, so in this problem, you are given that line segment. Well, let's start with the triangles. We're going to try to prove that triangle RST is the same size and shape as triangle XYZ. We're going to show that that's true using some statements and some reasons. We're just getting used to this new type of math here. Okay, what is marked in the figure? What's given to us? Well, we know that line segment RS has the same mark as line segment. It corresponds to the same place. RS is the same as XY. This is how we would write that given information. Line segment RS has the same mark as line segment XY. You know what, I'm changed my mind. We'll put that in a second. If you remember that, great. Okay, I'm just gonna say we're given the figure as marked. Sometimes that's the given information. So, hey, look at this figure. Can you say that triangle RST is congruent to triangle XYZ? Answer is yes. Well, this is a simple 4-step proof. And the end of your proof, the last statement, is going to be whatever you see right here on this line. This is what you're trying to prove, so this is where you end your argument. So the last step is what you are trying to prove. These are your supporting your evidence, your supporting statements. You're leading someone down the road until you all agree that this thing is true. So for this one, I'll start back where I was. Line segment RS is the same as line segment XY. Line segment RS is congruent to line segment XY. How do we know that? Because it's given in the figure. Okay, that's given to us. And now I've showed that a pair of sides are congruent. This side is congruent to this side. The next thing I'm going to do is I'm going to grab that angle. Angle S matches up perfectly with angle Y. How do I know? Because they have the same mark on them. They have just one little arc. That was also given to me. All right, what else was given? What else is marked up here? Good. Line segment ST is the same size and shape as line segment YZ. That is also given. So in this problem, this is as easy as this proof could be. I showed that a pair of sides were congruent. I showed that the angles in between those sides were congruent, and I showed that the last pair of sides were congruent. The reason these two triangles are congruent in this section of the book is because of side, angle, side, triangles, congruent theorem. This is a theorem in your textbook that you are allowed to use to show that two triangles are congruent. This might seem weird at first. We're going to practice all week and a lot of next week. So after a while, you'll start to get used to how these things work. Okay, here is a harder one. So we're going to do the same exact thing. This one has two little tricks to it. So instead of just showing the the side, angle, side, we have to work for it a little bit more. So that actually makes this one more fun, more interesting. So whenever you get a new figure, you want to just stare at it. What do you see? I see like a quadrilateral. Maybe I see that line segment AB has the same mark as line segment CD. Do you guys remember what these little arrows are for? That's right, that tells me that they're parallel. So I see marked in this figure that line segment AB has the same mark as line segment CD. I also see marked in this figure that line segment AB has that little arrow on it, just like line segment CD has that little arrow on it. That means they're parallel. Line segment AB is parallel to line segment CD. Now, even if these look parallel, I can't say that they are. I can only trust what's given in the figure. What am I trying to prove here? Do you guys see two triangles? Okay, so we have triangle, I think I'll do triangle ADC. The order matters how you think about it and how you look at it. Triangle ADC is the same size and shape as which triangle, do we think? Maybe CBA? Does that seem like it lines up to you? A is this one, C is this one. Those look the same to me. Okay, let's go for it. This one's a little bit longer. There's a little trick to it. So again, I can go back and stare at it. I have a pair of sides. Do you see any other things in this picture? Let's start with the side that we're given. So we have line segment AB is congruent to line segment CD. We know we're going to have a few other steps here. This is a 5-stepper. Which means and you don't always know how many steps the proof is going to be. Sometimes you have to erase. Sometimes the middle part is a little goofy. Sometimes you get lost for a while and then you're like, oh, I think I got it. So this is given to me because it was marked in the figure. What are we going to do with the parallel? All right, I'm going to help you guys out with this one. This one's a little interesting. Do you remember from topic 2, we had parallel lines like that? And then what's this thing called going across them? That's the transversal. I'm going to put little angle numbers in here. If those are parallel lines cut by a transversal. What do we know about angle 1 and angle 2? They're the same, right? Yeah. Okay, so the next step I'm going to do is I'm going to use the next given information. I'm going to say, hey, people, look, those lines are parallel. That's also given. And because those lines are parallel, angle 1 is congruent to angle 2. But why? What definition or theorem that we've used in another section of the book or vocabulary do you remember that explains this situation? Good. That says if the lines are parallel, then alternate interior angles are congruent. The lines are parallel, alternate interior angles are congruent. Are they alternate? Are they interior? Good, they're congruent. Okay, so that was the first trick to this problem. The second trick to this problem is to say, hey, the two triangles I'm trying to show are congruent are stuck together. This line segment AC is the same size and shape as this line segment CA. Because they're stuck together, they're the same line segment. It's the same distance to walk from A to C as it is to walk from C to A. So the way we would write that is we were like line segment AC is congruent to line segment CA. The reason for that is a property called the reflexive property. And this is a really common one anytime you have two shapes stuck together and you want to say that they're congruent. Reflexive property is a good one to use. It's essentially the idea that A is the same as A. Interesting. Okay, and then the last step, well, I have shown in my argument that a pair of sides is congruent. I have shown in my argument that a pair of angles are congruent. And I have shown in my argument that another pair of sides are congruent. So I'm allowed to say that these two triangles are congruent because of side angle side triangle theorem. And the angle is included between the sides. All right, that's how proofs work. Here is the side angle side congruence theorem. It says if two sides, it's just like the one we did, if two sides and the included angle of one triangle are the same, have the same marks as two sides and the included angle of another triangle, then the two triangles are congruent. That's in our textbook. That is a theorem that we can use in our proofs. Have a good day. Be good. Do your homework.